Hello everyone, my name is Shivani Jain and I'm an assistant professor in GEMS Greater Noida. So today we will be going through a topic called software testing. Software testing is one of the most important phase of whole software development life cycle. It comes before the maintenance phase. So before launching the software, what we are supposed to do is test it properly. Otherwise, the bugs in the untested bugs or vulnerability of the programs will fail the whole process of development. The whole purpose of a robust building software will fail if we will not test the software properly. So, by definition, software testing is basically the process of executing a program with intent of finding errors. So human is a creature which is who is goal oriented. So our intention when we are testing a software is to find errors. If we will focus on say let's suppose say if our intention in testing is to just prove that our software is perfectly fine, it does not have any errors, so we will test that way that the vulnerability of the programs or errors of the program will not come out. But if our intention would be is to find the errors, then we will execute program or test program in such a way that we will be able to find the weak points of the program or where it fails. So in testings are of two type. The first one is functional testing, also known as black box testing. In functional testing, we just focus if our program is working fine or not. And it means that given a input, it should give the expected output. If that is not the case, then we will say that there is some problem in the program and we have to correct it. We here in functional testing, we are not bother about how complex is the program or how code is working. We are just focusing if it is giving if it is giving us the correct output or not. So we basically build test cases for in functional testing. We build test cases, and if we and run the program and see if the output is coming what is expected or not. One of the functional testing is boundary value analysis. So boundary values are the weak, we can say the weak points, or where there is a higher chances of program can get program may fail. So what we do is see the boundaries of input values and see if they fail on boundary values or not. For example, we can learn this process with an example. So if we take a program that has two input variables, let's suppose x and y, and x has input domain, basically domain range of a till b, and y has range of c and d. So let's so this is like the domain or the range of variable x and y, and figure 4 basically represent this. So let's see an example and learn from the example how can we do boundary value analysis. So basically we have two variables x and y, and both of their ranges are 100 to 300. So we will build test cases. In boundary value analysis, we assume that the fault or when the program fails, it only fails because of a single error. So when we test x on its boundary values, we take nominal value of y. And when we test boundary values of y, we take nominal value of x. So what are the boundary values of x? Basically 100, 101, 299 and 300. And likewise, because y also have same range, it has boundary values of 100, 101, 299 and 300. So boundary value analysis, we have 4n plus 1 test cases where n is the number of inputs. Here the number of inputs are 2. So 2 into 4 plus 1 are 9 test cases. So for this example, we will have 9 test cases. As you can see on the screen, 200 and 100, 200 and 101, 200 and 200, 200 and 299, 200 and 300, 100 and 200, 101 and 200, 299, 200, and 300 and 200. So let's take another example. So in this example, what we are supposed to do is we are given a quadratic equation, and quadratic equations have three variables a, b, and c, and all of them have same interval 0 to 100. So some of the outputs we are expected is, it is not a quadratic equation, it has real roots, it has imaginary roots, and it has equal roots. So if we are given the problem of creating boundary value test cases for it, so let's see how should we do it. So this is the condition. This is basically the input ax square plus bx plus c. So we will be given the value of a, b, and c. So here n is 3. So we will have basically 4n plus 1 test cases. We are supposed to build. So 4 into 3 into 1 plus 1 would be 13 test cases. And expected values or expected output would be not a quadratic equation, real roots, imaginary roots, or equal roots. So when we let's see with the example. First we do is test the boundary values of a, and we keep b and c nominal. So what are the boundary values of a? 0, 1, 50, and 99. That is still case 4. Case 5 actually, because 100 is also tested. Then from 6 to 9 we test the boundary values of b and c, and keep the values of a and c nominal. Likewise, from 10 to 13 we are testing the boundary values of c, keeping the values of a and b nominal. So how should we interpret this answer is, if we take the first test case and we give the value a 0, b 50, and c 50. So expected output is not quadratic equation. So if our program is giving output other than this test case is like fails. So this test case reveals one weakness of our program. Likewise, in second test case, if a is given first one value, b is given 50 and 50, the output that our program should give is real roots. If it is not giving that, it means our test case is failed and we should correct that mistake. And likewise, we can do for all the test cases. There is an extension of boundary value analysis. It is called robustness testing. In boundary value, we have just tested the values that are inside the boundary. Here we extend a little more and text one extra value outside the boundary. And here total cases are 6n plus 1. So like boundary value analysis, we only assume that failure is because of a single fault, and we keep rest of the values nominal and test boundary values. Here we extend the limit of boundary, and here the total cases are 6n plus 1. So if we consider the same example of quadratic equation, total test cases here would be 19, because number of input is 3 and number of test cases in robustness testing is 6n plus 1. So in this example, till 1 to 7, we are testing the boundary values of A and keeping the value of B and C nominal. In A test, basically boundary values of A is -1, 0, 1, 50, 99, 100, and little above the boundary, that is 101. And the expected output is also written. And from 8 to 13, we test the boundary value of variable B by keeping the nominal value of A and C. And from 14 to 19, we are testing the boundary values of C. So how should we read this answer? In first case, if we give the value of A as -1, B 50, and C 50, the program that we have built should give answer it is invalid input. If it is not giving that, it means there is some fault in our program. Likewise, if we, let's suppose, take the example, test case 17. If we give the variable A value 50, B 50, and C 99, the output that our program should give is imaginary roots. If it is giving output any other than that, it means there is a fault in our program and we should correct it. So this is like one functional testing that we have learned today, boundary value analysis and its extension called robustness testing. Thank you for the time.